All right. Hello, this is Nick Klosky. I am one of the co-founders of Honeypoint 3D, and I welcome you to the September 2016 monthly 3D printing and 3D design webinar. So we've had a good month. We've done a lot of projects, added more to our classes, and as always, I spend about just 2 minutes or so going over what Honeypoint 3D is and what we can offer. So we are essentially, we help people get things 3D modeled and 3D printed. Now, that could be via education, which is what I'm in charge of. So we have classes on our website on intro to 3D printing, 3D CAD modeling with Mesh Mixer, free software Fusion 360, all sorts of online classes that you can take at your leisure to learn these really, really useful and awesome tools. The other side of our business is run by the other co-founder and my wife, who, if you don't want to learn, sometimes you don't have time or whatever, and you can hire us to create models for you that then you can get 3D printed with us or any of our partners. So however you want, get your models made. Learn yourself, or we do it for you. So as always, I would much prefer, let me move this down a little bit. I would much prefer that you ask me questions here on the webinar for things that you are interested in. I want to answer your questions. So for all of you who are listening to this live, please use the little question feature maybe down at the bottom or just in the chat to the right, and ask me questions, and I will be very happy to answer them. So I have two things that I'm going to go into today. One was a set of questions asked by somebody who emailed me named Russ, and I'm going to go into those. And then I'm going to go into using Fusion 360 to do some kind of awesome modeling that came our way this month, and I wanted to kind of share that tip as well. So I don't have any questions from our live people, so let me go to Russ's questions. So what did Russ ask? I've used Thingiverse to select some objects, but I can't tell if they are solids or meshes. Are they all mesh objects? Is there an easy way to tell? So this is a good question. It's kind of an interesting question, because at the end of the day, they're all computer files, right? So they're all 3D designs that are on your computer, but there is a little bit of a difference between a solid and a mesh. So if you look on Thingiverse, by far all of the models that you'll see on there usually have an STL called stereolithography, STL. Those are meshes, and in the background here, I'll bring up Mesh Mixer and kind of show you. So let me go and screen share this screen. And in the past, people didn't tell me this, but now I figured it out that you actually see me and the screen. So I'm just going to go here and go all the way there. Okay, so this is Mesh Mixer. We'll just bring in a little bunny right here. This is what's called a mesh. If you press W, you can see wireframe. You can see lots and lots of triangles. And down here in the lower right, it says that it's about 11,000 triangles. A really critical thing is if you go underneath this bunny, you can see that it's empty inside. It's kind of a hollow shell. Even if I fill that in like this, it is still essentially empty. If we go in and select some part of it and delete it, we can look on the inside of this bunny. This is what's called a mesh object. So it is just a series of triangles that are, pretty accurately placed and rotated to make a shape. But it's kind of hard to change. You would kind of think of this as digital clay. This is a mesh object. Let me go back here and go back. like this. And there I am. Okay, back here. So that is a mesh object. Those are STL files, and STL files, also OBJ and some other ones, really want a lot of complexity in them. You know, a cube would have 6 faces, but at a minimum, it would have, you know, each one of those squares would be into 2 triangles. So that would be a minimum of 12 triangles for that. You know, it wants complexity. So you would compare that with Fusion 360, where, see if I can screen share this again, like that. So this is Fusion 360. Where if we just create a box, you know, something like this, this does not have any triangles in it at all. It is what's called a solid. If we go in and do a little section analysis like this, we can start cutting this away, and it actually shows us this kind of a concrete texture in here. This is what's called a solid. Doing this little analysis right here. I can't really delete a face easily in this, and this cube is just a mathematical representation of a cube. If I double click on this down at the timeline, it says I can make the length 65, the width 80, and the height 55. And all it is a mathematical formula. It's not a whole bunch of little triangles trying to approximate where things are. It is actually a mathematical formula. Now, with that said, you can do things inside of Fusion, like, you know, remove sides of that, but it still is a mathematical formula. That is what a solid is. This is no longer a solid. If you look inside of Fusion, you have this little orange thing up here. This isn't a solid now, but it's still not a mesh object. If we saved this out as an STL, and you can see a preview of that, it saves it as triangles, and that would be a mesh object. So to kind of come back here and go like that. So I guess long story short, if you see STL, then that is by definition a mesh object. OBJs are the same thing. Now, OBJs can have 3-sided polygons, triangles, or they could have 4-sided, 5-sided, all sorts of things. But those are still mesh objects as well. It's really the program that is looking at those files that determines it's a mesh or a solid. So hopefully that answers that question. So another question asked by Russ, would it be better to just work with mesh objects unless there is some reason to convert for use as a solid? Well, so mesh objects can have much more complexity than solid objects really ever could. So if you create a 3D scan of somebody, that 3D scan is going to be a mesh object because the little wrinkles, the little, each individual little hair on eyebrows, all of that just needs a lot of complexity. And so you would stay within a mesh environment to work with that complexity. If you're dealing with, you know, geometric objects like a phone or something like that, you would probably want to start off in a solid modeling environment because geometric objects are much easier to model in there than they are in the mesh environment. Now, you can convert meshes into solids. It's a little bit tricky. There's some conversions that are very easy, where you download a like an STL file of a phone, and you can convert parts of it into a really nice solid. But once you start dealing with like 3D scans and things with a lot of complexity, you pretty much have to stay inside of the mesh environment if you want to keep that complexity. If you don't want to keep that complexity and, you know, kind of down res or, you know, lower the resolution, you can bring that into solids, but solids do not like complexity. They want to try to keep as little number of faces as possible, whereas meshes could go to hundreds of thousands or millions of faces, and they work totally fine. So it's really what you're using things for. Mechanical objects are better as solids, and organic, very detailed things are better as meshes. You can go back and forth between those a little bit, but that's kind of a generalization for that. So hopefully, hopefully that answers your questions, Russ. I know I don't think you could make it to this, but you said you were going to watch on the replay. So hopefully that helps you. So I don't have any questions or anything or comments from the people watching. So I just wanted to go into the other thing where I mentioned earlier, we had a request come into the rapid prototyping side of our business about how to create a kind of a blister pack. Excuse me, like a blister pack for like objects to fit inside of a case. So if I, let me just go back here and resize that. Blister pack like this. So if we look for an image, so the blister pack is things like this, where it's a great example. Actually, we can visit this page. I visited this one before, where you have something like a toothbrush, and you want to create kind of an indentation for that toothbrush to go into. This would be also better known as thermoforming, right? If you put a piece of plastic over that brush and kind of suck that plastic down, if you heated it up or something, it would create kind of a shape. Well, how to create, zoom in, something like this inside of Fusion. It was kind of an interesting thing. Let me go back here and go back like that. It was kind of an interesting question to figure out inside of Fusion. So I wanted to show you just very, very briefly how to do that. This uses one of my favorite tools called the surface modeling environment, or the patch environment. Really, really powerful, but people don't use it as much as they should. So this is a really good tutorial for that. So I'm going to show you very, very briefly how to create a type of a blister pack using Fusion. And then this will only take about 5 minutes or so, because I'll go through it quickly, but I wanted to show you how that it can be done in Fusion and how to do it. So let me switch over to Fusion. Let me go like this and like this and into Fusion. I'll get rid of this. Okay, so blank screen. I'm just going to create a sketch right in the center with a center rectangle like this. This will be kind of the top of our object, and we want to have it sit inside of a box. So I'm going to offset this, and you'll see why a little bit later. So that's the top of our box. I'm going to create a construction plane below the top of our box for however deep my box is. Click OK. I'm going to create a sketch on that bottom plane, and I'm going to go to Sketch, Project. So I'm going to project that outer rim. So click, 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 click. It doesn't look like I did anything, but I'm actually projecting it down onto the bottom sketch, and click OK and stop sketch. So now we have these two things. I'm going to just now I'm going to go into the patch environment. This is a pretty key thing. So a patch can create just single infinitely thin surfaces. So I'm going to create under here a loft. I'm going to loft the top of my package with the bottom of my package like this. And now we have, vaguely how it would fit in the package. You could get a lot more fancy with this, but that's what this is. So great. Because I created this from a sketch on the origin, so on the bottom plane, you can see that I'm perfectly aligned with this. So this is going to be very, very useful. I'm going to go back into model. I'm going to create maybe a box right on this bottom plane here. And we'll put the box here. And this would be the depth. You see the box is being created right at the top. And, I could make it a depth of 8 millimeters. oops, -8 millimeters. That's great. Let's create maybe a cylinder. We would have, another object that's going to go in our box right here. Pop that downwards as well. And we could do things with sketches, all sorts of things inside of here. But let's just say that we had, these two little things. They're not perfectly aligned, but that's okay. So we have these two objects here. If we look in bodies, we have a solid body, and a non-solid, an open body. Turn the origin off. So if we go into the patch environment, what I'm going to do is I'm going to create a, actually I'm going to do a few things here. I'm going to click on the top of this box. Actually, I'm not even going to do that yet. I'm going to create a patch. So I'm going to create a patch right here. That just patches the top of this. So it kind of filled in the top of the enclosure. We still have all of our bodies right here. But now let's do a really cool thing. We're going to go here to the trim tool. Or actually, I think I did this a little bit off. So kind of scratch that for a sec. I'm in the patch environment. I'm going to click on the top of this box and hit delete. Boop. Click on the top of this cylinder, hit delete. Because we're in the patch environment, we can actually open the tops of these. So now they switch to open bodies. I'm going to create a patch right here, like that. And now I'm going to go to the Modify Trim tool. I'm going to select the cutting tool, which is this box. So I'm kind of hovering right on the edge here to select the box. And I'm going to use the top of the box, this area, as the cutting tool, and click OK. Aha, it's cut out. I'm going to do the same thing. I'm going to go to trim. I'm going to hover right until the cylinder is selected. And then I'm going to use the top of the cylinder as the cutting tool. I know that now those are out. Now these normals are flipped because they're kind of a golden color. So we can fix that by going to Modify to Reverse Normal. I'll click on that and click on that. And now they're reversed. So now we have one entire kind of surface, and we can just, and you see there's multiple different bodies. So we need to stitch all of these together. We just hit the stitch button up here, and we just hit everything that needs to be stitched, like that, and that, and that, and we just click everything and click OK. Now we have just one body right here, and we go to Create and Thicken. And we just select everything like this, and we can thicken reverse like this. If we thicken in the reverse, it doesn't affect our outside at all. If we thicken the other way, it does affect that, but we don't want it to affect that. So we'll thicken in the reverse underneath like that, 4 millimeters, whatever, click OK. And now we have a solid body. That is essentially our blister pack. We can go in and edit these however we want. We can go back up to the model environment, create fillets, whatever fillet, whatever fillet makes sense for our object. Repeat the fillet on this, whatever makes sense for all of these things. Those are probably too large of a fillet for what we need. But you have created a thick body that you can now do things with. There. So hopefully that was just a super quick example how you can create, how you can use the surface environment called the patch environment. It really, I think, should be called the surface environment. Maybe I'll put a Fusion 360 request to change that. But how you can use the patch or surfacing environment to do some really cool things. It never ceases to amaze me how valuable that environment is. Model is great, sculpt is great, but the surface environment or the patch environment is really, really powerful. So I want to see if we have any questions or anything here. We don't have any comments from people. Oh, I see that Russ actually is online. So Russ, if you do have any questions on any of the things I talked about, you can ask me. But if not, no worries. Hopefully I've answered your questions. But if that is it, then I think today we will wrap up. I wanted to also mention that I can share my screen one more time here, like this. If we go to Amazon and you type in "getting started 3D printing," our book comes up at the top link right here. It's a #1 bestseller in 3D printing books. And this is authored by us, by Lisa and Nick. I am Nick, and Lisa is my co-founder and wife. And so this is a really great start to this. You can get it on Kindle and paperback. It's only about $15 on Amazon, and it is. We can actually look inside. A lot of text, but also a lot of really nice pictures on the inside that we created and our team here created. So really, really good resource for you if you want to learn about 3D printing. So I don't see any other questions or chats from the people that are signed on. So I think that this will be a nice, good little tip tutorial webinar for this month. And I look forward to getting your questions and everything else for next month. So thank you so much. If you're watching live, or we have a lot of people that watch this in replay, thanks so much. And we will see you next month in October. Bye-bye.